in Arabic. So, okay, well, it just doesn't work then. Hello, Houston. We have been right at the wrestling back and forth about where we finished last time. We're going to pick up in the middle of that today and start with the last few comments in the general section dealing with basic fundamental perceptual processes as they bear on language. And so today what I want to do is essentially to look at specifically issues related to attention, and I'm not quite sure why that is where I am. Hang on a second, let me jump ahead a little bit and see what I want to really get to here. That's what I'm trying to do, and that is to basically integrate the features of vision and hearing. That last one scared me a bit. We're going to get to it in just a second. Well, let's see what we're actually going to talk about here today. Not that we're disorganized, just running a little tight here. Basically, when we are communicating with each other, which is kind of what I want to talk about here a little bit today, we normally do it either by speaking or by writing. And we find that the same general areas of the brain are used in various ways depending on which process we're actually engaged in. And so the reason that I've actually spent as much time as I have on perceptual processes and a little bit of today has to do with the fact that the overall issues that we're talking about are really quite similar. And when we look at reading a newspaper article or somebody's love letter or anything like that, we're using the same basic processes as in fundamental perception. So I'm going to kind of base my comments on that. But when we start trying to integrate vision and hearing, I would point out, for instance, things like the fact that I sometimes ride a bike from my house over to the nearest market, which is about half a mile away. It's not bad. Most of it is on suburban streets, which happen to be 4-lane. And unfortunately, because there's a bayou between the lane headed one way and the lane headed the other way, I tend to get on the opposite traffic lane so that I can simply hang by the curb and get to the street that I want to turn into. But of course, every now and then, since it is a boulevard, people are coming the other way. The advantage that I have is that the passing lane is much smoother than the right-hand-most lane, so people in general tend to stay over in that lane. And to acknowledge the fact that I'm breaking the law, what I tend to do when I catch the driver's eye is simply nod my head, and I don't mouth thanks. What I mouth instead is thank you. And the advantage is that I'm giving them 2 signals rather than 1. Just thanks, could cover a lot of different possibilities. And so my intent is basically to catch their head, I nod slightly and say thank you, just as a gesture to the fact that I'm in your lane, I'm in your lanes, and I thank you for not killing me as a result of doing that. But that's just one of the situations where we actually integrate senses. I have a demonstration that I think will illustrate the effect even more powerfully, the fact that we do pull information in rather smoothly. Do you remember, for instance, a number of years ago when you used to go riding in the car, particularly when it was before we legally were required to put youngsters in a seat, a safety seat? You and I used to bump around on the back seat sometimes, and of course if it was a long vacation trip, do you remember car sickness? That visited in my life several different times during the course of my growing up period. But my mom always got a great deal of credit from my father, from my sister, everybody else, when she lifted me up onto her lap in the front seat and talked to me sweetly and calmed me all down. And sure enough, pretty soon my stomach, my illness, my upsetness went away. Well, the problem there is actually the fact that when you're sitting down lower, you're still subject to dad turning left, dad turning right, and so forth. But if you don't have the visual input to document that or to understand why you're turning in a particular direction, all you're left with is the effects that are generated by your semicircular canals, the fluid that is flowing back and forth, moving the crystalline structure that bumps hair cells on one side to indicate you're moving one direction, and hair cells on the other side to indicate you're moving the other direction. What she did by lifting me up into the front seat was actually to supply a visual explanation for why it was that my semicircular canals were telling me I'm going one direction, telling me I'm going the other. Simply by lifting me up to the front seat, she really didn't have to speak sweet nothings to me and what a wonderful child I was or anything. I mean, it was true, but she didn't have to deal with that because really all she had to do was lift me up high enough so that my eyes were over the windowsill. And then I could see why we were turning left, right, and so forth. There's another way that I want to demonstrate this, which is a little more directly, that is the integration of senses and how smoothly it can happen. What I'd like to do is have you take your hand and hold it up about 15 and 18 inches, a comfortable distance from your head. And then what I want you to do is to not move your head. I want you to move your hand back and forth in front of your head, using only your eyes to focus on the lines, okay? What you're trying to do is keep the lines on your hand, the creases on your hand, in focus, okay? I love to have people walk in when this demonstration is going on. Okay, now stop your hand. Now what I want to do is change the rules. What I want you to do is move your hand same way you were before, but I want you to move your head but keep your eyes still. Okay, same degree of movement of your hand. Which way are the lines more clear for you? The first or the second? When you were moving your head, or when you were moving your, when you were moving your eyes only, or moving your head and your eyes, head, not your eyes, I should say, you're keeping your eyes still. Which way is it more clear? Now, if you don't get the correct answer to this, we need to go back to more basic stuff. Try it again. Put your hand up and move the hand, but not your head, just your eyes to keep track of it. And then hold it still so your eyes are focused on it, and move your head, but not your eyes. And which way are the lines on your hand more clear? When you're using your eyes or when you're moving your head? Yeah, moving your head. And the reason is because in that case what you've done is the reverse of what I described a minute ago. You've added in the effect of the semicircular canals. Because when you're moving your head but not your eyes from the motion across the background can detect that motion is going on. But what's been added into the signals that you're processing is the stuff coming from the semicircular canals, because that fluid is sloshing back and forth as you turn your head each direction. And the combination is, with your eyes against the background judging movement and the added information from your semicircular canals, it makes the eyes much more efficient and accurate in their operation. That is but one of the many different, very subtle ways in which we actually utilize combined senses in various times. What I've actually demonstrated there is what's called the vestibular ocular reflex. Vestibular ocular reflex. You can dazzle them at cocktail parties this weekend with that kind of a demonstration. So now, let's look specifically at, I guess I described it for you. Let's look specifically at speech perception. One of the topics we're moving toward, and I'm picking up kind of the sensory aspects of that particular feature here. Basically, speech is perceived by integrating at least 3 different sources of information. Before I identify them for you, consider what you would perceive to understand if you heard a speaker say, I'm going to blow this, neighborhood. That's hard to do. Neighborhood. Okay? If you hear somebody do that, they may catch their breath or momentarily choke or something like that. So they, in the continuity of their language, they give you the first and last sound of what were a 3-sound word, three-syllable word, and they simply did not offer the second syllable. You and I have no trouble integrating that into neighborhood, even though if you listen to what you actually heard, it was neigh, cough, hood. We have no trouble with that. But in essence, what we're dealing with there is an integration of sorts. The bore has been simply filled in by us, given the speed of our processing characteristics. So one of the things that we utilize in speech perception is specifically, I didn't realize I was going to get to that. Let me back up a second, and I'll talk about that in just a second. But the thing that I was running toward here is boundaries and their importance in words. You and I can take neigh, cough, hood, and integrate it into neighborhood, recognizing that the boundaries are before the neigh and after the hood. No problem. I did a word association study one time when I was in graduate school with 1st, 3rd, and 5th graders. And it was an argument that my dissertation director and I had that was resolved by going into the lab and trying things out. What we did was to do a word association study that involved about a dozen each of nouns, verbs, adjectives, and then a limited number of other words like once and various things like that. I will never forget one of the first graders whose association, in that case we were giving them the word and then timing how long it took them to give us an association. I'll never forget one of the first graders who, when given the word once, paused only very briefly and then said, "Apana." And I thought, when I was translating it a little bit later, I finally realized what had happened. And that was that in her case, she had not yet spelled out or identified the boundaries of the word once relative to upon. Because in her case, it was a very classic childhood sequential association rather than what you and I do, which is a word substitution task. So for her, once had always been used and only been used in the phrase once upon a time as her story started. And so for her, at least, the first thing that once made her think about was apana. And yet that kind of, makes us go, I mean, it's cute, but it's not correct language in terms of the way you and I have bounded the various terms that we're using here. So boundaries becomes one of the things that is important, establishing those in developing communication patterns. Now let me jump into what I started to talk about there a minute ago, and that is phonemes, the sound units, the fundamental units of sound, and the variations that they have with them. We talked earlier about the idea that phone companies had a lot of trouble developing a computerized system by which to give you information when you need to look up a number or something. The progress was made, actually, when they developed a sequence such as I put on the screen there for you a little bit ago. And that is what's plotted here are two different things. The one is, it's a recording of someone saying simply, "to catch pink salmon." Not a phrase of particular distinction, just "to catch pink salmon." It's been recorded. And then what's laid out on the graph there, first of all, is a kind of a collapsing time clock of how long it takes to say each of those effects. But the other thing, and in many ways the more interesting thing, is the other side is showing the frequencies in cycles per second of the tones that are just momentarily there and then gone. In some cases, just microseconds, very milliseconds, very brief periods of time. And they started looking at that and stumbled into what turned out to be one of the keys to machine translation of language. And that is the fact that if you look at the diagram there are actually three different frequencies that tend to show up repeatedly in that particular diagram, if you look at it. The easiest one is the one around 3,500 cycles per second, okay? That one is pretty obvious. But if you look at the diagram there are at least a couple of other tones that are also markedly there, more noted by their presence than their absence. I would suggest there's another tone around 2,400 cycles per second, which for this particular speaker always tends to be there. And then there's the third one. It's a little harder to pick out, but it is also there, and that is down around 700 or 800. And again, I stress, that is for this particular speaker, okay? It turns out that what's actually been identified there are what are called formants. That's the technical name that has now been applied to them. And it turns out, as they studied the occurrence of formants, that those formants are always there. That is, there always tend to be primary signals that are present anytime anyone is talking. You, me, anybody. It also turns out that if you're listening to a bass, somebody with a very low voice, those formants are compressed. That is, the top one may be down around 2,400, even 2,000 if you're talking to somebody with a very low bass voice. But the formants are compressed. What is not altered, however, is the ratio of the first to the second to the third formant. That is, and I'm just estimating numbers here, but if the first one is 800, the second one is 2,400, and the third one is 3,600, it isn't quite, as you can see. But that ratio is kind of 1 to 2 to 3 between the bottom one and the top one. Well, that 1 to 2 to 3 ratio turns out to be a constant. So that if, in fact, the top frequency or the top formant of a bass speaker is at 1,800, he'll also have a dominant presence of 1,200 cycle per second tones and 600 cycles per second. I'll get it out eventually. Cycle per second tones, okay? On the other hand, if you're listening to a soprano with a very, not a singer soprano, but somebody with a very high squeaky voice, what you find is the ratio of the first to the second to the third formant is still there. It's just that the top frequency may be up to 4, even 5,000 cycles per second. So the entire thing is spread out, but the ratio is constant. The ratio is the key element. So although it spreads out as you listen to somebody with a higher voice, it's the ratio that ultimately becomes the basis for our understanding of language and for our ability to do machine translations of that kind of thing. Okay? And so in essence, we'll come back and look at that later when we look at specifically phonemes. But another feature that I want to talk about here is the importance of context. That is, when a word is used or in what context it's used is pretty simple to illustrate. For instance, I've got a model of my family car here, of course, on the desk, and we'll close in on it in a minute and show it to you. It's going to be down a little bit right there. If we can drop down and focus on that, I can use a phrase such as, the eel was still attached to the car's axle. It was dropped, but we checked and the eel is still attached to the car's axle. We could talk about the fact that the eel was still attached to my shoe if I'd stumbled. We could also talk about another element. She was trying to eel the orange. And even though I've used, I've not pronounced one of the phonemes, in each case, it's very clear that I'm talking in one case about a wheel, I'm talking in the second case about a heel, and I'm talking in the third case about a peel or peeling. Okay? And so in essence, the context within which these words are utilized is often crucial to our ability to actually understand them. That is, yeah, we can define peel and heel and wheel and so forth, but in fact, it's the context within which those words occur that often leads us to be able to identify them with much greater precision. So the role of context is really quite crucial. We're talking about a banana, we're talking about a peel. Talking about a car, we're talking about a wheel. And so basically, what I've illustrated here is the importance of context. And what I'm really arguing is that if we summarize how we go about doing perception of speech, I'm going to put the list on the screen here for you for a minute, and I'm going to summarize three major features that we've been kind of lumbering through at the end of the last lecture, and also this one. Okay? Boundaries, phonemes and variations, that is fundamental sounds and variations. We'll come back and talk about that later. And also context. Those are the three major factors we're going to need to keep in mind when we start looking at how we go about talking to one another, communicating with one another, or the context within which a particular word occurs. Okay? And so now as we shift into the next section of material, I'm going to be looking specifically at issues related to attention. All right? And in that case, we're going to look first of all at some of the factors that impact attention. But let's think about that for just a second. Consider the last time you used a car to get somewhere. Supposing you were rushing off to visit somebody. Think about the various things that happen to you. First of all, as you're moving along, you press the gas pedal so that you can keep up with your speed. You don't want to be going 20 on an interstate. You'll get rear-ended. Okay? On the other hand, you don't want to go 80 on the interstates because you'll sometimes get arrested. So speed becomes important. You have to judge relationally how fast you want to make your car go based on the pressures on the gas and the brake and so forth. Secondly, other key element is you have to steer the car. You have to stay to the right of the dotted line in your lane, but not so far right that you drift off the edge of the highway, whether there's an edge marker there or simply a change in color to indicate, where the edge of the highway actually is. You may be operating the FM radio at the same time to listen to your favorite station. That is until a song you don't like comes on, and then you're going to be operating that radio to alter it and find another station. Okay? Along your journey, on the road, not an interstate, but on a suburban street, somebody starts to back out of their driveway right into the path of your car. And if that happens, even if you've been talking to somebody, what I've really led into is a whole bunch of different things are going on when you and I are, quotes, driving the car. We may be talking to somebody else, listening to the radio, watching the road, estimating our speed at any given time, and so forth. And then all of a sudden, if something changes dramatically and catches our attention, what happens to the conversation? If you're in the middle of talking to somebody, what happens to the conversation? The silence suggests you guys have never had such an incident. Better watch very... Yeah, you stop talking. And in fact, the interruption is so severe that it may be the case that you jump right back into the sentence exactly where you were before. That is, you've literally just stopped the processing. The problem is a channel limit, a channel capacity limit that you've got. It takes a certain number of skills and operations to drive your car, but once you know how to do it, it becomes relatively automatic, which we'll talk about again later. But if all of a sudden you have to apply more skills in terms of slowing down very rapidly or steering around something, you don't have enough skills or channels to carry on the conversation while you're using those capacities to save your car's fender and so forth. Same time, you may be thinking, if you're driving to go visit a friend, you may be thinking about the last date you had with that person. You may be considering how hungry you were, which was the reason you agreed so readily to meet her in the restaurant. You notice as you're driving along that the wind is going so hard. First of all, it's pushing you slightly in the car, but in addition, it may have a flag on one of the car dealers absolutely flat to the wind, blown out straight from the pole. And when you get to the restaurant, you engage in a different set of activities. Among other things, what you're doing is scanning the crowd. And key in that case is finding your friend in all the hubbub of the restaurant. But when you eventually find that friend among all the people, it turns out she's already gotten a table for you, for the two of you. So you're able to walk right over to her, sit down, and start the conversation and the meal and everything else. That's a pretty typical experience. And yet, there's some other things going on in there. For instance, if you're talking to a friend in a subtle voice, and we'll talk about voice loudness a little bit later in a particular situation. But in essence, when you're talking to somebody, if the restaurant happens to use a PA system to announce when takeout orders are ready or something, they read off a 3-digit number. 126 is ready. Well, it turns out that PA system is loud enough so that if your friend is just talking along in a subtle person-to-person level of conversation, you can't hear that person when they're talking if the PA system goes off. And so in that case, the signal has been overridden and you're unable to pay attention to it. We'll talk some about that as we look at the various kinds of attention. But in essence, what I want to do is to define attention, and I guess we blew past the demonstration. Well, let's see if it's there. It isn't, so we'll just go back and look at the very beginning of the tape when the attention definition was on there. But in essence, what I'm doing is to define attention, the process we're going to look at here, as the tendency of an organism to focus on certain aspects of current ongoing experience, okay? Stimuli, thoughts, activities, and yet you're ignoring, when you're doing that, you're ignoring other aspects. So the technical definition, again, that I'm giving you, I've added some verbiage there, is simply the tendency of an organism to focus on certain aspects of current ongoing experience, such as stimuli, thoughts, or activities, while ignoring other aspects. That is basically what's involved in attention. Think about the last time you stood very close to a screen door. You may have been talking to a salesperson outside or calling in your brother or sister or anything like that. But if you think about it just a second, you could actually change your focus from outside, which basically ignores the screen. That is, you're looking through the openings in the screen rather than concentrating on the wires. But in fact, you could just as easily stand 6 inches or so from that screen, change your focus, and put the main focus on what you're paying attention to then is the wires of the screen. You're looking directly at the screen. So that screen in one case is the object of your attention, and in the other case it isn't. Another one that we'll talk about later is the cocktail party phenomenon. You're sitting in a group or standing in a group at a party, talking to somebody or in a group about something, and you're interested in it, you're paying attention, you're nodding agreement, and so forth. All of a sudden, you hear in one of your ears that your name has been mentioned in a group next to you. Your name. And all of a sudden what happens is your attention goes there. You're still standing in the group because you're socially engaged with them, nodding agreement and maintaining eye contact and so forth. Your attention, however, is on your oral system, your hearing. What the heck are they saying over there? What did they say about me? So although you're going through the actions as if you're continuing to participate in the group, you really get sandbagged if all of a sudden somebody turns to you and says in the group you're with, "Don't you think so?" And you have to go back and repeat it because you've been going through the actions of looking like you're participating when in fact your attention is directed somewhere else. Now I'm going to argue that basically there are 3 broad factors that influence what you and I pay attention to all the time. And I'm going to divide them out basically into 3 different types of factors which affect attention. One of them is external factors. These are factors that combine all of the various aspects of the physical stimuli that are hitting us at any given time. Okay? Secondly, I'm going to talk about internal factors, those that determine or govern internal aspects of what we're doing, what we're observing, and why. And then finally, I'm going to talk about factors that are really not clearly either external or internal. And so I've called those essentially mixed factors. The reason is that the origin, the source of them, is mixed or debatable. Okay? Involves some aspects of the stimulus, but your experience with those stimuli can also impact what's going on. So in essence, what we're going to do then is spend some time looking at a sample of various kinds of external stimuli. For instance, one of them that is external factors that are very easy to identify include intensity. Okay? Suppose you're listening to a television or viewing a television program. It's a very intimate story of some sort, deep love among 2 people in a national park or something, and all of a sudden the program breaks for a commercial. And the net result is you almost get blown out of your seat by not so much the increase in colors and brightness, but the loudness of the material that's hitting your ears. Okay? That is enough of a potential factor for drawing attention that the government actually has limits on the decibel level that is allowed, the increase in loudness that is allowed on commercials, for commercials in commercial television. It can't increase above a certain average noise level, sound level, in the program that you're actually watching. That's one factor. There's another one, and that has to do with size. That is, how large a particular stimulus is in your environment can make a big difference. I don't have a specific, well, I do, actually. Here's one. If somebody extends their hand towards you, you do not think this is somebody whose fingertips drag on the ground when they're walking. Okay? You make the adjustment of the fact that that hand is extended towards you, and therefore it's bigger simply because it appears closer to you. But size does attract your attention. And another example of that is this one. This is a very old illustration. I keep using it because I have never found a newspaper that had headlines that large as cleanly laid out. This was, in fact, I was on leave at Stanford the year that Reagan won his first election as president. And the San Francisco Chronicle was quite impressed with it at the time, given that he was a native Californian and so forth. And that was the headline that day. I guarantee that the first word you saw when you looked at that screen was Reagan, even though the rules of reading English are start at the upper left, go to the right, which means basically what you should have read first was election extra if the rules of reading were the only thing you were following on or attending to, but you didn't. You later got around to the fact that it's the huge gains for the GOP is probably the second thing that would draw your attention, and then the name of the newspaper and so forth. But in essence, the size of the headline is designed specifically to attract your attention and, of course, sell newspapers. But when you and I look at a newspaper in the rack, the first thing we pay attention to, based on size, is the headline. We can also look at movement. Movement is a very effective way. That's the way you find somebody in a crowd. If you're at a football game, you're meeting somebody in the area outside the gate. What you're looking for is if you see that person before they see you, one of the things you'll tend to do is move your arms. You wave them back and forth over your head. What you're doing is using that movement to attract attention to yourself. It can be done with a camera using a zoom lens here, so the emotion is implied, but your eye, I'll use the pointer here, is pretty much drawn to this general area of the slide simply because all of the other motion implies that was the focal point of the zoom that went on in that case. Number of different ways to illustrate this, okay? Any major ad campaign features repetition. Coca-Cola has been advertising for years. And I remember the very first Coke ad that I ever focused on when I was driving with my parents in East Tennessee, where we used to live. I remember seeing a Coke advertising that said, Coke, it's the real thing. Okay? That was one of them. It opens now with one of the most recent slogans used is Coke, open happiness, implying the idea that you open a can or uncap the bottle. But if you notice in those slogans, it used to be that it was always Coke, it's the real thing, but now they've changed it. So about every 2 years they change that slogan because what they're really trying to hang in your mind is the name of the product, not the effects that it has. And that's the reason that the name of the product will be there, and then there'll be some tagline that they'll run with for a couple of years. But the point there is repetition. Absolutely the best one that I have ever seen like this, and I should not slight Pepsi here. Pepsi has the same general attitude in the things that it is advertising there. But my favorite example was one that was done on television back when it used to be legal to advertise cigarettes. And Salem cigarettes, which I believe it still is. I don't smoke, so I don't know. But at that time, they had an ad with a tagline to it that was something like, remember, you can take Salem out of the country, but you can't take the country out of Salem. I guess that was a reference to the flavor of the cigarette. And I remember seeing a commercial one time, a television commercial, in which the announcer, the chorus, a female soloist, and the print on the screen, in one way or another, over the course of that 30-second or 1-minute commercial, introduced that phrase, remember, you can take Salem out of the country, but you can't take the country out of Salem, something like 40 times. It was stunning, the number of times they were able to do that in the limits of the commercial. And it was all building us up toward a particular effect which was devastating at the end of the commercial. Not bad, but just interesting, very effective. Because at the end of the commercial, the announcer said something like, remember, and then he, the chorus, the female soloist, and the screen are all simultaneously saying, as it's being spelled out on the screen, Salem, remember, you can take Salem out of the country, but, and there was 5 seconds of silence. Everybody in the country, if they're like me, was saying to themselves, you can't take the country out of Salem. It was just a very effective use of repetition. First of all, to attract attention. And then secondly, to having take advantage of that, get you halfway through the cycle and turn you loose. And now you've got people actually mouthing your slogan as they're watching the program. That was, in my mind, one of the most effective commercials I've ever seen. I can still cite to you the fact that the information number for Metro here in town is 713-635-4000. The reason I know that is at one time, years ago, it's probably been a decade now, they had a commercial that said that number over and over and over again, the same basic idea. So repetition is a very effective way of getting, and when I wrote these notes, I didn't even have to look up that number. I guarantee you it's correct. I learned it based on repetition. And finally then, there's one other factor that I want to talk about at least briefly, and that is on screen, contrast. Oh, sorry, I have another illustration of movement. This is a sign like we used to have in, somebody told me there's one down in San Jacinto, but what's involved here is about a 2-foot sphere where the hemispheres rotate in opposite directions, and the entire mechanism is moving around in a circle, flat to the ground. So in essence, what you've got are 8 or 10-foot spires of neon projecting off 2 hemispheres that are rotating in opposite directions while the entire sign is turning. So it produces a very complex pattern. And again, movement just attracts your eye to that sign, which is, of course, their goal. But then finally, after movement, I've already talked about repetition. Sorry about that. This was another example of repetition. Libby's got annoyed with the fact that they were losing ground to Campbell's. And so for a while, they ran an ad campaign that talked about, remember, if it's Libby's, Libby's, Libby's on the label, label, label. And they had a little fun with themselves. But the intent was to increase the frequency that you and I heard the competing brand's name. That was exactly what was involved. And then the one that I was reaching for is contrast. And that shows up in a number of different ways. Avis, as a rental car company, has never caught up with Hertz, which is the #1 rental car company. But for a while, what Avis was doing was running an ad in which they trumpeted the fact that they were #2. Remember, Avis is #2, we try harder. They tied those two together, and what they were building on was the idea that they used the contrast of them not being the biggest in a country where we pride ourselves on the biggest, the fastest, the smartest, whatever. And they used that contrast in order to pull us into the idea of you get better service if you go with a person that's trying harder. That's another example of contrast, okay? Traffic signs are in colors that stand out from the environment. And if you'll notice, worldwide, red is the only color which is associated with one of the most crucial things we do when we're moving around in a neighborhood, and that is, at some points, you have to stop and give way to other people to make sure that you don't miss that opportunity or that signal. Drawing your attention, they use red, and that's a worldwide phenomenon. Red is a very unusual color in nature, and so we tend to use it to attract attention. Things like road signs and so forth, they're green or brown or blue or something, but they tend to fade off into the environment more so than things with strong contrast like the colors. Now, in essence, I also want to look at the mixed or debatable factors, and the list is much shorter here, but I think you'll understand exactly what I'm going after when you look at something like this. Okay? You may have seen this plane at some point at Hobby or here in Houston. When that plane lands, people interrupt what they're doing to go over and look at it. It's simply the product of a mutual ad campaign between Southwest Airlines and SeaWorld in San Antonio. And so what they did was take one of their planes and simply paint it to look like a whale. And people interrupt the walking down the hallway when they see that just to go look at it. And you can see here what I'm talking about when I talk about mixed or debatable factors. Because in essence, if every plane were painted to look like a fish, that would not stand out at all. So in essence, it is the plane itself and the way it's dressed, based on your past experience with planes, that really makes that one stand out. Braniff went even further. They actually hired a South American artist, an artist by the name of Calder, to do a major statement on its plane. They actually were leading toward, the airline went broke, so I don't know whether the ad campaign really worked or not. But I was in New York one time when this plane landed at the big airport there, and again, same thing. Staid old New Yorkers interrupted what they were doing going down the hallway to walk over to the window and look at that plane, again because it was so unusual among all the planes that we have experience with. So that's a mixed or debatable factor that's essentially based on novelty. Okay? We also have another factor in addition to novelty, which basically involves, whoops, I'm ahead of myself, I didn't add two things here that I meant to, but the other is familiarity. That phenomenon I used earlier with the cocktail party. Okay, where I talked about the fact that you're in a conversation and all of a sudden your name gets heard. The familiarity of your name to you use it all the time, cuts right through whatever you're doing and gets your attention. So the familiarity of something is partly a function of what the stimulus is, but it's equally a function of your experience with that. So that it's combining both internal factors and features of the stimulus itself. If you're handed a photograph, what you look for is not the strangers, because you don't know them. What you look for is the people you know. Who's there? Who do I know? So again, familiarity is what draws your attention. I've heard, I've not been able to track down the research on it, but it is thought that when you buy a new car, one of the things you are most likely to continue doing is continuing to pay attention to ads for that car, because you tend to seek affirmation of the fact that you made the right decision. So then finally, let's look at the internal factors that I seem to have been so eager to get to here a minute ago. And let me suggest that there are at least a couple of these that we can talk about. One of them is set or expectancy. Okay? That really influences what you see. I'm going to put a sign on the screen here. It may show up on a computer if that's what you're looking at, but think for a minute whether you can see an error in this sign. Okay, well, my button is going the wrong way here. We'll get it there eventually. There we are. Nowadays, we don't have problems like that on term papers because of the fact that, of course, most term papers are turned in by computer. But when I was in graduate school and grading papers as a graduate student, one of the common errors that we would find is because you were typing them on paper. And when you finished a given page, you had to go through the process of inserting a new page in the typewriter before you could continue your thoughts. And so in essence, you were saying the sentence over and over and over to yourself up to what was to be the next word, and oftentimes you repeated that word at the end of the sentence and again the beginning. So you would read on one page, now is the, and then turn to the next page and the time to do whatever. Okay? That is an error. You'd be amazed when I'm doing that in front of 500 people in an introductory lecture. I can regularly get 1 or 2 or 3 people who will hold their hand up in the face of everybody else having indicated they see an error and declare they don't see a problem. And they will sit there, look right at that, and read repeatedly, now is the time. Now read it again, now is the time. Concentrate on it, now is the time. And then all of a sudden you'll hear, or somebody will whisper to them, and then you hear, now is, oh, and they finally caught it. But that tells us something about the nature of the reading that we do. That is that we tend to integrate units. You'll see me come back to this when we're looking at things like eye movement, significantly later in this set of materials. There's another one here. Unfortunately, I asked in the lecture in the studio here, and we don't have anybody that reads French. But if you read French, read that to yourself for a moment in good, fluent French. Don't labor on any given word. Just read it through smoothly. And you end up mouthing, and I don't speak French, so tolerate me being a little loose here. But in essence, what it sounds like by somebody who speaks good French is pas de leur own canoe. Okay? And if you set somebody up to think in terms of French, you can then ask them point blank, can you translate that? And they will tell you that it's a sequence of words, and it is. They were put together strictly for the sound, not for the meaning. And so in essence, if you say over and over, pas de leur own canoe, you're never going to catch on to the fact that if you split it this way, what you're actually intoning in elegant French is paddle your own canoe. Pas de leur own canoe. Okay? But because you're set to think of French, you don't tend to pick up on what you're actually intoning in that situation. So set is a very important theme in determining what happens to our paying of attention. And then another factor, which I'm going to skim over here, is basically motives or interests. Okay? If we show you an ambiguous picture very rapidly and take it off the screen, 20 milliseconds or something, you will tend to be, if you're hungry, you're much more likely to perceive food objects in that ambiguous picture than if you've just eaten. So your interests in that case, your motives, will dictate what you actually see. We know that advertising firms tend to focus on things like youth. I don't think I've ever seen a person over 25 driving a GM car, for instance. Okay? They focus on youth, they focus on sex, they focus on several themes that tend to be central in our lives in order to move products. What they're trying to do is to attract your attention by giving you things that you're familiar with. And so motives and interests are two major things that impact what we pay attention to. Now let's look at essentially a second element that I'm going to identify as also impacting what we pay attention to, and that is our set. And that is essentially an adjustment or orientation or preparation to respond in a particular way. Okay? It orients how we tend to respond in a given situation. And it can be determined by a number of different factors. For instance, prior experience. Okay? That usually is very helpful for us, having past experience when we're trying to interpret a new stimulus. The best predictor of tomorrow's weather is today's. I'll never forget one time the director of the National Weather Service was in Congress asking for additional billions to run the National Weather Service. And at one point, a senator kind of rocked back in his chair and asked point blank, what's the difference in accuracy if I simply look at today's weather and predict that that's what's going to happen tomorrow? And the answer is only about, I don't remember exactly, but it's only about a 20% increase in accuracy. Okay? And so the congressman, as you might expect, rocked back and said, so we're paying whatever the salary figure was, the budget figure was, for a 20% increase in accuracy. But of course, then the idea is that when major storms are coming, that can also be important news to have. So there are reasons for paying for it. But in any case, I keep coming back to this product, but let me show you another set effect. Oh, this one first. Do you see any problem in this Vermont country town? You have to look closely. The answer is actually there, although maybe a little hard to see. Concentrate on the sign. It's a little hard to see. The sign up here repeats what's on the road. But if you'll notice, the word ahead is misspelled. But your set is such that when you look at that, it's, you know, the letters are generally correct and you don't really pay that much attention to it. It's a good thing I took this picture when I did. It's kind of dark because there wasn't much light at the time I found it. But it's a good thing I took it when I did, because the next day there was a very embarrassed town sign painter painting a big black blob on the street and correcting his spelling error. The one I wanted to show you was, this is going to be slightly out of order, but let me see if I can fit this in here. Give me just a second. Oh, yes. Okay. What I'm going to ask you to do, if your last name begins with A to L, I want you to close your eyes. I'm going to show the group from M to Z a sequence of information, and then I'm going to stop, we'll switch sides, and I'll show that group another sequence of information, okay? So if your last name begins with A to L, close your eyes for a minute, and for the group whose last name begins M to Z, hang on, I want you to just look at a series of pictures, about 8 or 10, without comment, okay? Shut your eyes. Okay, if your eyes have been shut, you can open them, and if you've been watching material, now shut your eyes. And we'll do the same thing again. You're just going to look at about 8 or 10 pictures in sequence without comment. Okay, everybody can open their eyes now. Look at this picture and tell me how many of you see a human face, a head. How many of you see an animal? And interestingly enough, at least initially in the studio, it's a completely different set of hands that went up. Because some of you looked at pictures like this, some of you looked at pictures like this, and so basically what it's done is to set you to interpret this either as a human face or as an animal. Okay, but if you look at it, the only thing that's in common to both an animal and a human is this is the tip of the nose. If you're looking at humans, this is the nose, this is the upper lip, this is the jawline, this is the ears, this is a pair of pince-nez glasses like Franklin Roosevelt wore years ago, and this is just a glitch on the nose. But if it's a rat, if it's an animal, that's the nose, these are the front paws, this is the tail, these are the rear legs, these two round things are ears, and this is the eyes. So in fact, the pattern is ambiguous. But I set you by showing you a series of pictures of either the human or the animal to interpret that in terms of your most recent past experience. So experience can influence what's going on in a given situation. After I got my PhD, my then wife and I took a trip to London, kind of in celebration before we started our first job. And I'll never forget that a bus drove past with GRE right on the side of it. And of course, having just gone through graduate school, I was very sensitive to the initials GRE, Graduate Record Exam. But it turns out it was part of an ad where the Guardian Royal Exchange Bank in London was advertising with the word great. And so what they did was simply spell out in big letters GRE followed by little AT. So you ultimately would read great, but they had impacted you at the same time with the initials GRE. When I looked at that, I thought graduate school had just followed me into London. That is, it was nothing more than the GRE that I was sensitive to, again, based on past experience. Now, in addition to prior experience, your internal state can also impact what you tend to experience. If you've had no food for hours, it increases your perception of food-related items when you're driving down the street, anything. Or think about the first babysitting job you ever had. Maybe you were 8 or 9, maybe 10. But if you're the biggest kid in the house, responsible for a bunch of younger people, every rattle is a burglar. Okay? Every time a bush hits the screen, you're sure somebody is breaking in to do mayhem upon you. Okay? Every creak in the heating system means somebody is there, right? And all of that has to do with, essentially, internal or individual states. You're so uptight anyway because you're responsible that it tends to bias the way you're perceiving each of the other things going on. Or take a look at this one. Do you see a problem here? Takes a minute to look at it, but actually if you look, this is actually from Norway. The verb drink is not spelled correctly for English because this is for Norwegian, a Norwegian ad. Okay, again, if you're set for the ad, which you've seen many times, you tend to blow right past the fact that it's the product that's being advertised there. Okay, the third thing that I want to show you is social factors that can also impact what you're doing. And this is an experiment that goes all the way back to Solomon Asch. It's become a classic in the field. But what Asch did way back in 1955 was to bring in a bunch of participants who were going to sit about 8 or 10 feet from a screen, simply a projector screen, like you might look at slides in a classroom or something like that. And what they did was to give a standard line as a reference, and then they would ask 7 people sitting in a row in the same order each time, which of the following really represents a match? Which of the following matches the standard line that we've given you there? Unbeknownst to the single participant in this experiment, that male was the only one who was actually the subject in the experiment. The other 6 people were responding to the first person who was asked. That is, at the other end of the line was somebody who was reading a script. And that script indicated that across 20 puzzles like this, they were to actively pick the wrong answer, and they had been told which one to pick on each of the challenges. And so if this is one where they're giving you the wrong answer, what that person would do is look at it and say B, and then 5 other people, B, 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 B. So if you're the only actual subject, though you didn't know it at the time, you've now listened to 6 seemingly rational fellow students pick the wrong answer. In the data, in the data which was collected in there, about 3/4 of the people will go with the majority, unless one other person indicates correctly that it's A. Okay, and in that case, they will then go with what they think is the actual correct answer. And did you notice, in fact, that I didn't give the correct answer? I didn't notice anybody jump right up and say, wait, that's wrong. It's C, which is actually the correct answer. But in fact, pressure, social pressure, such as I applied as a professor, meant you kind of accepted it as the right answer. In a group, it was the group effect which pressured the individual to accept the right answer. Question these things. That's why you're in college. But that's a classic demonstration of the effects of social factors on perception. Third factor that I want to talk about is stimulus variation, and I'm going to skim this because it doesn't greatly impact what's involved here. But in essence, one of the classic studies of this was done fully half a century ago now by Bexton, Heron, and Scott. What they did was to put students, in an enclosed room, just a small room, that had an air conditioner on at a reasonably loud levels, A, to control the temperature, and B, to create sound that would basically mask any other sound they might hear. Their vision was limited by cutting a ping pong ball in half, and then fitting the 2 results over the eyes. So they had light coming in, but they could see no pattern, and the thing was too close for them to focus on. So basically, they eliminated the normal variation that you and I are subject to. Even if we're sitting listening to a lecture, we can fidget, we can move anything we want at any given time. That turns out to be relatively important to us, because in this constant environment, the net effect was that they gradually lost their ability. They reported a loss of ability to organize their thoughts. Their performance on mechanical tasks when they were tested deteriorated, and eventually they had to terminate the experiment because people were actively hallucinating in this particular situation. Okay, the lack of stimulus variation, it was repeated a couple of years later by Lilly in what has become it was the predecessor of the modern day water tank, where you can rent something where you get into a thing where they do pour salt into water, and then you just soak in the water. That actually came originally from Lilly's experiment, where what he did was to have you completely undress, get into a water tank, and they attached a mask to you, and then you were just supposed to hang in the water. It was like a 6 by 6 foot tank, so you weren't going to touch the edge anywhere, and they'd adjusted the specific gravity, so you didn't either sink or float. You just hung there. They got the same effects in about 2 hours. So the point is that stimulus variation is very important to us in terms of maintaining stability and the ability to judge various kinds of stimuli to which we're subjected. Now let's look at constancies. Constancies are unique in a different kind of way. And what I'd like you to do is to basically look at this. I'm going to suggest that there are essentially 4 different types of constancies that you and I are subject to, one of which is shape constancy. If you look at this conference table, it's been pictured from the end slightly off center. What is the shape of those objects at each chair on the table? What's the actual shape of each of those objects? What would you guess they are, since it's a conference table?
Paper?
Yeah, they are. It's pads of paper. And so you would report to me likely that it's what shape? What's the shape of those objects? Again, you got to get on the mic to get credit. But in essence, it's rectangular. But if you look at the actual images there, all you're looking at on the right side of the table is trapezoids. And all you see on the left side of the table is parallelograms. There is not a single rectangular object that you're actually looking at in that situation. And yet you're correct. I mean, you've inferred from the actual signals what the correct shape actually is. And in fact, what's illustrated there is what's called shape constancy. That is, when we're looking at a rectangle, all of these other shapes, unless there's another cue like an irregularity or something on the surface, will be interpreted simply as a rectangle. Shapes have a constancy, so even though we see things like pads of paper at an angle, we have no trouble at all actually perceiving or determining what the correct shape actually is. So in that case, we're dealing with shape constancy. A second one illustrated here, okay? A mailbox from any angle, you can still infer to be a mailbox given its height, the color that's usually associated with it, and so forth. And a door. If you think about a door, you almost never look at a door exactly head-on as a rectangle. You see it in many different angles, and yet you have no trouble realizing that it is a rectangle. Okay, that's shape constancy. We can also talk about size constancy. Slightly different feature here that's involved, but in essence, if I had a Emmert's law essentially is that the size of a retinal image is inversely proportional to the distance between the object and the retina. Okay, and that's what's illustrated here. The fact that the same size object being further away subtends or intercepts a smaller angle than does a large one. And we are phenomenally accurate with that. If I were to give you a yardstick and have a sample of sticks, say 12 feet away, 10 or 12 feet away from you on the far side of a room, if I asked you, looking at this sample, and the most you can get it is like 2 feet away from your eyes, you could look at that and pick, if I had sticks that range from 33 to 39 inches, half-inch increments, 95% of us would pick the correct stick. And it's based simply on size constancy in that situation. We're very good at making those kinds of judgments. There are two other types of constancies that I'm not going to spend any time on because they don't really bear on what we're doing. But brightness and color constancy are also involved, operating for us. So now let me focus specifically on three different types of attention for the rest of the time today and some of the time that we'll cover tomorrow here. Okay? Attention basically allows us to focus or concentrate our mental processes in such a way that our thinking can focus on limited aspects of the environment which we're processing. If you think about the example I gave you earlier of driving, or even think about stopping in a forest as you're walking along in a forest, you are literally subject to concentrating on what could probably be documented as millions of different features. Each of the leaves of each of the trees in that forest you could potentially stop and look at. We don't tend to do that. When we go to the forest for a walk, we enjoy it and all the things that go along with that. But our processing is not simply overwhelmed by all the things that are going on in the forest. We learn to pay attention, to focus. How we do that. And that process of focusing, paying attention, is key to our ability to operate our apparatus, our processes of thinking and so forth. I'm going to suggest, and we're going to look at here in the next bit of time, three different general classes of attention. One of them is divided attention, which we'll have an example of. One of them is selective attention, and one of them is saccadic eye movement. Strikes you as kind of a strange reason, but there is a reason why that is actually identified as a third type of attention. And we'll come back and pick up on each of those as we talk about them. And in fact, if you think about it for a minute, I didn't have time to set this up today, so I don't get to demonstrate it as effectively as I wanted. But think about the fact that, suppose you're in a lecture class somewhere, two TAs stand up simultaneously and both start talking about, one of them is saying something like, don't forget the first exam is this Friday and we'll be covering the material from chapter 1 to chapter 5 or whatever. While the other one is standing up saying, don't forget that you forgot to pick up the papers that were turned in last week because they're in Dr. Foster's office, and so forth and so on. In essence, what you're suffering there from is that is the only way you can survive that, is to utilize what is called divided attention, okay? Which is simply attending to two or more, I notice I misspelled or there, apologies, simultaneous stimuli, both of which require appropriate responses occasionally. If one TA is talking about the next exam and the other is talking about a paper of yours that may be thrown away, you need to pay attention to both of those. And in fact, a lot of research has been built around the effects that are generated by divided attention. In divided attention, you're paying attention to more than one thing simultaneously. There have been a lot of different studies on this. One of the more interesting ones was done by David Strayer, Drews, and Johnston in 2003. Dr. Matlin talks about that in her book, and I want to spin off from that because there are some things she doesn't mention that I think are also interesting. The study basically was very simple. It had an experimental and a control group. In the control group, what they were asked to do, those subjects were asked to drive a simulated auto. So in essence, they were sitting at a screen and they were operating the pedals, steering, and so forth and so on. And what they were doing was following a car reasonably closely, which occasionally slammed on its brakes for no particular reason. And so in order to keep from ramming that car, it was your task to step on the brake as rapidly as possible, even while you kept up with the car, which was going along at a fairly good speed. And so in essence, in that case, it was really simply a reaction time. When that body starts coming towards you too rapidly, you push the brakes. Very simple. In the other case, what the experimental group did, same task, they had to avoid hitting the car, but they also had in their hand, in the car, a hands-free cell telephone. So in fact, what they were expected to do was to carry on a conversation as they were theoretically driving the simulated car. And what they did with that, to make the phone use legitimate, was that they actually were carrying on a conversation with the research assistant. So of course the research assistant governed the topic and kept it moving in a variety of different ways. It wasn't a boring thing that you could ignore. You really had to attend to what was going on in the call. And in that situation, when you measure that condition under light traffic, where there's not that much going on and therefore the car ahead of you is not stopping that often, there was almost no difference, slight difference favoring the control group with no cell phone activity. But both of them were reasonably accurate and missed almost none of the opportunities to put on the brakes as demanded. When there was heavy traffic, the cell phone users were significantly slower in braking. Coming into school here a couple of weeks ago, instead of coming in on an interstate, I got off on a local street because there was a traffic blockage on one of the interstates I used to come in. And I noticed at the traffic light, kind of as you're under the interstate, about to turn under it to get onto the street, the local street that I was using, there was a person talking on the cell phone right in front of me, in the car in front, the only car in front of me. And he made the turn all right. He was fine. I mean, the light went green. The other lane had actually emptied before he moved, but he did in fact pull into the road and pulled over to the right lane. But then as I watched him, because he was first of all going much slower and there was traffic in the left lane, so I had some trouble getting around him initially. So I followed him for some little bit of time. Speed limit was 35. He was doing about 28, 27, pretty consistently. But what was also happening, if you watched him, was that every now and then he'd wander off the right side and correct it fairly rapidly. And then he'd start to wander into traffic, and what called my attention to it was the fact somebody honked at him. I mean, he got far enough over so that he was endangering the next traffic flow. And ultimately, the only thing that was accounting for that was that cell phone. That was clearly it distracted his attention. And so Strayer and Johnson actually started way back in 2001 doing basically cell phone versus no cell. And reaction to a red light, for instance, is impacted or impacts. Let me back that up again. At a red light that goes red suddenly, the speed with which you can impact or put your brakes on is what they measured. And it turned out there was a whopping difference as to whether the person who was doing that stimulated driving was actually using a cell phone at the same time. That is, having a cell phone basically increased the reaction time from 530 milliseconds to 580. That is, it added about 10% to reaction time. Okay? The proportion of people who missed that traffic light jumped from 2.8% to 6.6%. It more than doubled when they were talking on the cell phone. It more than doubled the number of people who missed the traffic light entirely. Never stopped at all. Now that's not such a problem if we're talking about the difference between 2% and 6% in that high impact area, high activity area. But I thought about it as I was writing these the other night and counted and realized that I go through 10 traffic lights between my office and home. So I do 10 traffic lights each way, each time I commute. And so where we're talking, about only 2 to 6% among 100 instances, Actually 10,000. Sorry, I miscorrected. I should not have said that. That was 2 to 6 out of 100 is what's involved. But essentially, if you go through 10 traffic lights, that 2 to 6 times accumulates. It adds. So the odds go up. It's just basically that I was playing with the numbers, being very defensive there. But the fact is that cell phone is a distraction. And it turns out, well, we're going to put in hands-free cell phones so you don't have to hold them. Turns out it makes almost no difference in the ability to miss stimuli, whether it's handheld or built into the car. It really doesn't matter. It's actually the cognitive task of talking into the phone that takes most of our attention. The mechanical task of whether you're mashing buttons on a radio or to adjust the volume or holding the phone really has almost no impact. In fact, there was a classic study by Schneider and Schifrin done way back in 1977 that showed that practice can make perfect, that is, can improve performance. But as the complexity of the task goes up, the benefit of practice decreases to the point where practice cannot overcome the effect of complexity. Okay, so that even in a complex task, if you practice it enough, redundantly, over and over and over again, you can essentially shift into what's called automated behavior. It's an automatic response. You don't have to think about it. And in fact, it becomes integrated simply as driving, or something like that. So the complexities of turning on the ignition, putting it in gear, looking with each mirror before you know, all the different rules that go into driving, by the time you're an experienced driver, are simply integrated into, I'm going to drive to the store. And that's really all you do. You get in the car, do everything automatically, and you get to the store with reasonable safety. But it turns out that what Schneider and Schifrin were able to demonstrate is that as the complexity of that task goes up, the net effect is ultimately you cannot move yourself to automaticity. It just doesn't happen. The task dominates, and that really is probably, as much as anything else, a function of the cognitive complexity of whatever task you're actually attempting to perfect. So let's look at another type of attention, not divided, but rather selective attention. And in that case, we're going to define selective attention as you see here. The ability to focus on one activity, conversation, physical activity, voice, whatever, and ignore everything else. The punctuation looks a little funny there because what I was trying to do was dot the voice after the voice to suggest that there are actually a number of other things you could put in there that may be seeking your attention. All right, as in our example earlier, in which two of you that we talked about, where two TAs were reading a different message, it is possible to focus on only one of those speakers and basically ignore the other one. The usual result is the fact that much of one information is simply missed. You do not detect it at all. You don't perceive it. A classic study with the technique was actually developed by Cherry way back in 1953, in which he performed what has become a classic experiment where participants listened over earphones, stereo earphones, to different information on both sides. And in fact had two completely different tracks of information that they were listening to, a completely different message going into each ear. And in fact that is called dichotic listening. That's the technical name that is applied to it, dichotic listening. And yet in that situation, when participants are given permission to listen to only one of the two messages, that is, not just that you and I are forced to pick one or the other message to really attend to, but they were told, they were given permission. It's okay if you want to concentrate on only one of these. The process that's involved there is basically what is called shadowing, okay? It's a repetition of a message as it is being heard. That's the same kind of skill that translators at the United Nations are doing. If you've ever listened to a minister from another country give a talk at the UN, we normally have simultaneous translation into many languages, one among which is usually English. And they're essentially doing shadowing in that situation. Well, in this particular thing that's demonstrated here, what the listeners could do is track the semantic content of a message, started in the right ear, shifted to the left, and returned to the right. Now think about that for just a second. Even when they were instructed only to attend to one ear, the classic experiment, in fact, let me read ahead here to show you the other kind of thing that's involved. And I don't have the study right here. I guess I was going to talk about that a little later. Well, I'll come back and pick it up later. In essence, what I'm trying to demonstrate here is that if you're listening to information in two ears, and you're asked afterwards about the ear you were asked not to, or given permission not to attend to, almost all of the semantic content of what goes in here you miss. But you can still remember, was it a male or a female? Were they talking rapidly? Were they talking slowly? Were they talking softly or loudly? And so forth. And so basically what we can suggest is that it's the physical features that in fact you will retain even while you miss most, if not all, of the semantic content of what's involved there. So basically what we're arguing here is that basically physical features aid in listening in confusing type situations. And identifiable sensory characteristics that have been studied, the effects of which have been studied, are things like pitch, pacing, fast or slow, even detectable rhythms, cued by things like that. Rhythm is not quite used in the sense of music, but rather in terms of, do you have friends that often say to you, you know, they make a statement and then say, you know, or you know what I mean, or something like that? That's essentially a rhythm device. It also can be used, gives you time to organize. You don't want to give up the verbal channel, so you'll make a statement, well, it really means that what we've got to do is, and now you're trying to think of all the different things you might have to do. But it's basically to retain control of the verbal channel. But those are physical features of the text, so that if that's going on, if those features are present, they can be detected even while you miss the intent of the message itself. Sound intensity, how loud it is, that is a factor. The location of the source, we'll talk about here in a minute. Even Cherry showed that selective attention is much harder in the binaural dual listening task than it is in his binaural listening task. And what I mean by that is, in this case, it's two different signals in two different ears. But consider what happens if we mix both signals and put them into both ears. That's different, because the physical stuff has been divided for you, one versus the other ear as to what it's hearing. But in the case where we combine those two signals, we have both people talking fed into both ears. That makes it a significantly more challenging task. And yet what was able to be demonstrated here is that we've examined a lot of different auditory phenomena, visual selection, attention, and also how those factors bear on what we're looking at. This was the point at which I wanted to do a classic demonstration, and in the lateness of time, I cannot find, so I'm going to have to hold off on showing you the Stroop test, because an amazing amount of work has been done by the Stroop test, which I'll just name because we've got it labeled here very effectively, but I'll come back and demonstrate it for you in the next lecture material. And basically, I'm in fact going to, hang on here a second, I'm going to skip ahead because we're not going to talk about that right now, so I'll drop that in later, and instead what we'll do is drop into the third general type of attention that I do want to spend some time on, and that is that what's involved there is the movement, how you move your eyes across a line of print when you're reading it. And in fact, the key element that we define there is basically a saccade, S-A-C-C-A-D-E. It's the rapid eye movement or shifting of visual focal point that occurs when reading or viewing visual patterns or scenes, often called saccadic eye movement. Okay? I don't know whether that one ran very close to the screen. It's basically sufficient if you just leave it that way. The only words that are missing are visual patterns or scenes, often called saccadic eye movement. Okay? In order to understand what's happening, we have to study a bit about the structure of the eye and the accuracy or interpretability of visual information that can be achieved at varying distances from the focal point. Okay? For instance, if you focus for a minute, take just a moment, focus on a period or the dot of an eye right in the cognitive psych, the book that you're utilizing there. Just focus your vision on the dot and notice what happens. I'm telling you just to look at the dot and notice what your visual system actually does in that situation. Okay? It may take 2 or 3 seconds for you to observe what's happening. Has the eye actually done what you asked it to do? Has it remained steadily on that dot? Because what usually happens is that it jumps off to the right or the left, up or down, and you have to haul it back. It jumps off the other direction, and you have to haul it back, and it never, when you look at something, What's really being demonstrated there is that you are looking in the region of, rather than specifically at, that particular object. Okay? Now, in general sensation perception work, what's really involved there is the prohibition of the preventing of adaptation. You think about the fact that if you stand at the top of a set of stairs, for some reason idiotically staring at your toes for 3 minutes, 5 minutes, 10 minutes, it is just as important to you when you step forward to know exactly where that next step is as it was when you first stopped there to pause and look. And so basically there is a tremor that is built into the eye all the time. And that is called physiological nystagmus. That's the tremor that is basically in the eye all the time. I have not seen, and I'm going to try and track down an answer to the question because it occurred to me as I was writing this, that the saccades that we're talking about here bear a remarkable resemblance to the actual physiological nystagmus that is going on, that tremor that is always there, basically to keep things from fading away, from adapting. Think about it just for a second. Can you feel your watch? Those of you that are wearing a watch, without wiggling your hands, can you feel it right now? Are you wearing a ring? Can you feel that? And basically what's happened to things like that is they've adapted. They are there so constantly that they've simply faded away out of consciousness. You're not paying attention to it. On the other hand, with the physiological nystagmus, it's deliberate. The tremor is there specifically to keep you from being able to look at a given place and wipe out your vision. We'll pick up the conversation next time to more precisely define saccadic eye movement.